Okay, so this will be our lesson for today, which is about shear and moment function ng ating beams. Okay, so for today, here is our outline. So very short lang yung magiging flow ng discussion natin for today. Shear and moment function ng beam, we have yung procedure for analysis, and then solve problems or example problems to show kung how siya i-solve, no? So learning outcomes natin will be to calculate yung shear and moment functions of beam between applied discontinuities. So ba ibig sabihin yan? And then to solve for shear and moment values between specified regions ng function of x. Okay? So ayan, shear and moment function. So beams are structural members which carry lateral loading. So ibig sabihin, mga loadings na naka-perpendicular dun sa bending axis niya. So as we can see here sa top, ito yung axis ng beam natin. Ang usually kini-carry niya is yung naka-perpendicular sa kanya. Yung mga applied forces niya is mga naka-perpendicular sa kanya, usually, no? Kaya the design of beam requires detailed knowledge of the variations of the internal shear force and moment acting at each point along the axis of the beam. Kasi po, depende kung hanggang saan yung hangganan ng mismong applied force natin. Nagbabago yung value ng internal force na kinakalculate natin. So from the previous lecture natin, yung internal forces na kinakalculate natin is nakaspecify siya sa isang point lang, no? Na usually nagpo-fall siya sa madaling point. Okay? Paano kung halimbawa, ano siya, doon siya sa kalagitnaan ng mismong loading natin. Halimbawa, triangular yung load natin or trapezoidal, it makes our calculation difficult, no? Kasi you have to correctly assume yung mga forces na yon dun sa mismong beam natin. And dito sa consideration natin for the shear and moment function, hindi natin usually kino-consider si normal force. Hindi dahil hindi siya importante because of the following reason. So number one, in most cases nga, si beam is used as a load-carrying member. Meaning, lahat ng forces or loading na particular na nag-act sa kanya is naka-perpendicular sa kanya. So, ibig sabihin, pag naka-perpendicular sa axis niya, wala tayong normal force. Ang normal force kasi dapat, kung ito yung cross-section ng beam natin, dapat dito sa, kung halimbawa ito yung section ng beam natin, no? Dapat yung force natin is towards dun sa cross-section natin. So, doon lang siya magkakameron ng normal force. And usually, kapag sa structures natin, si beam, ang pinaka-function niya is to carry yung mga applied loads na nakapatong sa kanya. Okay? So, wala siya usually nito. Okay? And then, the beam's resistance to shear and bending moment is more critical compared dun sa normal force natin. Of course, the normal force is also critical kung malaki yung value, depende sa function ng beam natin. Pero all in all, the most important values na kino-consider natin are the shear and bending moment natin. So yun yung pag-aaralan natin ngayon. Depende kung saang point. Okay? So the variation of the shear and moment along the beam may be written as a function of position x, okay, in terms of x daw siya, and can be obtained by using the methods of section. So yung ginagawa natin, no, nagkakat tayo ng mga segment sa kanya. Pero ngayon, ang gagawin natin, magkakat tayo ng segment every time na meron siyang change in loading, no? Like for example, itong given beam natin, we have a simple supported beam, meron tayong hinge at left side and then roller at right side. And then nakita natin, yung mismong tributary load natin o yung rectangular applied load natin is hanggang point B lang, no? So once na nawala na yung load na yon, ibig sabihin yung internal forces dito sa portion na to will be different from this one. Okay? Kasi wala nang nakapatong na load sa kanya. And then makita natin dito sa point C, nagpatong ulit tayo ng additional load. So that will cause again a change in our internal forces. Kaya ngayon, ang gagawin natin, to calculate for the value of shear, kailangan magka tayo ng section sa kanya ng kung saan siya nagbabago ng loadings, no? Ang usually ang nagiging cut natin is between points, no? Kung saan naka-designate yung mga point natin. Kasi usually yun yung mga kung saan siya nakalagay yung mga loadings o yung extent ng loadings natin. Kaya makita na dito, yung first cut na ginawa is dun sa between A and B. So, ibig sabihin yung internal reaction natin na kukunin is dito sa gitna niya. So, i-assume natin from the origin, usually taken from the outmost left side nung pinaka-beam natin. Tinawag natin siyang X1. So, in terms of X, ibig sabihin. And then dito, yung second segment natin, since nagkameron ulit ng change ng loading o nawala yung mismong rectangular load natin, nag-assume ulit tayo ng distance mula dun sa pinaka-end o left side natin. Then dito, another segment kung saan nagkameron ng presence ng applied load. Kaya, nag-apply ulit tayo ng section dito and then yung distance na from the left end. Ngayon, bakit kino-consider dito sa left end natin? Para makuha natin yung reaction ng force, yung change ng force. Kasi once na nakapag-create tayo ng form ng function o ng equation galing sa isang segment, ibig sabihin, ito yung point B natin, yung from left ng B, papunta dito sa A, yung formulang ginamit natin for X1 o yung equation na nakuha natin for X1, pwede natin gamitin para hanapin yung internal reaction nun. So, halimbawa, itong distance na to ay 3 meters, no? Pero ang pinakuha sa problem is at 1.25 yung pinakuha. Okay? So, pag nakuha natin yung equation in terms of x, isa-substitute lang natin yung distance na required. No? So, halimbawa, yung required na kasunod is 2.75. Pero meron ka ng equation. So, equation na yung gagamitin mo para makuha mo yung internal reaction natin, o internal force natin, which is much more easier kung halimbawa several points between dun sa certain loadings yung kukonsider natin. Okay? So in general, the internal shear and moment functions will be discontinuous or their slope will be discontinuous at points where the type of magnitude of the distributed load changes, okay? Or where the concentrated forces or couple moments are applied, okay? So, basta may change in loading, dapat mag-cut tayo ng segment nun, okay? So dito, yung representative natin na point A, B, C, D, so yung in between na nilagyan natin ng mga cut, okay? So procedure for analysis nito. So determine daw natin again the support reaction kasi magkakat tayo ng segment. So gagamitin natin yung support reaction to calculate for the equation. Okay? Then specify daw natin yung separate coordinates x natin. Ibig sabihin, i-isolate natin yung segment natin and then i-reference natin siya doon sa outmost o yung leftmost na side natin, no? Na x, and then section the beam to perpendicular axis, and then ayan, ma-determine natin yung V and M natin by using yung same natin na sign convention for internal forces ng mga previous lecture natin. And then to check down natin yung result, we can use pag nakuha natin yung moment equation, derivative daw natin, makukuha natin yung shear. So dapat equal siya doon sa shear na na-calculate natin. Then para ma-check yung shear, i-derive daw natin para makuha natin yung loading niya o yung W equivalent niya. Okay? So I think this particular procedure does not make sense at present, kaya i-apply natin sa example so that we can appreciate yung procedure na sinasabi niya. Okay? So we have here this one. Pinapadetermine yung shear and moment ng beam as a function of x dun sa mga natin, kung saan nag-change yung mga mismong segments natin. Okay? So, for a while na lang. Let me check na yung... Okay, so we have a fixed beam. Okay, fixed beam yung given natin. Wait lang. Okay, so... Ayan, so... Ayan. So we have yung fixed beam natin and then meron tayong rectangular load and then applied concentrated tsaka moment. So kung fixed beam tayo, kung i-ano natin yung kanyang free body diagram. So laging ganoon na yung consideration yung ating procedure, no? To simplify yung problem, we always need to create yung free body diagram natin. Okay? Nandito sa end, we have our since fixed yan, meron tayong horizontal, vertical, and then meron tayong moment. Okay? Don't forget, fixed ay may moment, no? So lagyan natin ng points. Tawag ko itong point A, point B, tsaka point C. Okay? So this will be AY, AX, tsaka moment at A. Then we have point C, so wala naman yan. So uh, kasunod natin is yung ECL natin. So ECL natin is for our rectangular load. Okay? So that is just yung magnitude niya 4 times 12. Okay? So we have 4 times 12. We have 48 pounds. Kips, no? Kips yung given niya. Okay? So that is applied doon sa center natin. So 48 kips. Okay? Yung ibang applied load natin is ito, 60. And then we have our moment na 100 kip foot, kip feet. Okay? Okay, so kunin muna natin yung support reaction natin. So sa summation of Fx is equals to 0, taking the positive. So Ax is equals to 0. Summation of moment papunta kay A is equals to 0, taking to the right as positive. So kunin natin yung distances. Okay, so we have ito yung half niya, 6 foot. And then 20 minus 6, this is yung remaining natin, 14. Okay? So we have 48 times 6 plus 60 times 20. And then yung moment natin na applied is positive kasi clockwise din siya. Then we have minus MA is equals to 0. Yung MA natin by taking yung summation o yung uh, additive ng mga values, and then we have 1588 keep fit, okay, as our moment. And then for our horizontal, our summation of moment naman tayo at point C, summation moment at C is equals to 0. So taking to the right, clockwise as positive, counterclockwise rather. So we have 14, and then si AY will produce clockwise, so minus AY times 20. And then si MA will be positive kasi counterclockwise siya. And then si 100 foot will also be present at that point. So minus 100 is equals to 0. Okay? So substitute natin yung value ni MA. So minus AY times 20 plus 1588 minus 100 is equals to 0. 48 times 14, 1588 minus 100. Transpose natin si AY. So 2160 equals to 20 AY. Divide natin both side by 20. We have AY is equals to 108 kips. Okay? So for checking, we have summation of Fy is equals to 0. So we have AY minus 48 minus 60 equals to 0. So we have 108 minus 48 minus 60 equals to 0. 0 is equals to 0. So tama ibig sabihin yung forces natin. Okay? Yeah. So ito ilipat ko lang dito sa kabila. No? Okay, next. Ngayon is pinapahanap yung um, value ng yung shear and moment natin for depende sa segment natin, no? So ibig sabihin, ilan yung segment natin? We can cut this segment into 2. So, pwede itong segment na to and ang segment na to. Okay? Then yung sa pinaka-last na point, we can also do that, pero pwedeng left side lang yung consider natin. Okay? So, yung first segment muna tayo, first cut. So, cut AA, tawagin ko na to, cut BB. So, section AA. Okay? So, pag section A yung pinag-uusapan natin, ang range na kino-consider natin is yung X value niya hanggang left ng B, no? Hanggang left ng B. So, ibig sabihin hindi kasama yung dito, hanggang left lang B. Okay? So, let's show our cut. So, ito yung beam natin. Okay, ito yung cut natin. Ito yung ating load. Okay, then copy natin yung mga applied. So, meron tayong AY na ang value is 108. Then, meron tayong moment na ang value is 1588. Okay? Again, yung gagawin natin, yung pinaka-end niya, consider natin to as X. Okay? Then dito, ibig sabihin ito na yung base nitong rectangular load natin. Okay? So, ibig sabihin yung equivalent natin o yung ECL natin, okay? Yung ECL natin dyan will be equal sa, ito ay 4 kips, no? Kip 4 foot. So, we have 4 times X na yung value niyan. So, this will be 4X. Okay? Kasi X na yung base natin. Then, kung ano natin, dapat kunin natin tong distance na to. Yung distance ng ECL, that is X over 2 o half niya. Okay? So, pakita natin yung internal reactions natin. So, we have ito yung ating normal. Then, yung shear natin, dapat mag-cause ng clockwise. And then, ito yung moment natin. Okay? Now, we get yung ating shear and moment with respect dun sa ating function na ng X. Okay? So, pwede dito i-disregard na natin si normal force, no? Hindi na natin sasama si normal force. So, summation of Fy tayo is equals to 0, taking upward as positive. So, that will be 108 minus 4x minus V is equals to 0. So, yung formula natin will be V is equals to 108 minus 4x. So, ito yung formula natin for shear. Summation of moment tayo. Tawagin natin tong at S. S is equals to 0. Taking counterclockwise as positive. So we have yung 4x muna natin. Magta-travel siya ng 0.5 ng x. Okay? Then we have yung next, ito yung una, no? Next is yung ating 108, clockwise siya. So minus 108 times x. And then we have moment na clockwise. Ito. No? Counterclockwise. So we have plus 1588. And then we have ito, naka-clockwise din. So plus din siya, m is equals to 0. So simplify natin. So dapat ilagay natin lahat to the other side para maging positive si m. So lahat ng pwede i-combine, combine natin. So since ito walang mako-combine kasi magiging x squared to, ito ay x lang and then ito is whole number. This will be 2x squared minus 108x plus. So tinranspose na nga pala natin. Okay, and then minus 1588. Okay, so this will be our equation for moment. So ito is applicable lang sa ang distance lang. Yung range nito will be kung saan lang yung cut section natin, kung hanggang saan yung boundary niya. So point A to point B. So ibig sabihin itong equation na to na nakuha natin is applicable lang siya for 0 less than or equal sa x less than or equal sa 12. Okay? So in between hanggang 12. Ibig sabihin nun, mula dito sa 0 hanggang dito sa 12, ito yung formula natin. So kung halimbawa pinakuha ko is at 8 feet, no? Ano yung magiging value ng internal force natin at 8 feet? Ang gagawin nyo, sa-substitute nila yung 8 feet dun sa value ng x dito sa formula. Then makukuha nyo na yung v at saka yung m. So hindi na kayo kailangan maggawa ng free body diagram pa ulit for another cut. Okay? So basically ito, again, is pwede siya kung saan mo siya segment kinat. So itong segment na to is from 0 to 12, kaya valid siya doon. Okay? So ibig sabihin kung gusto natin sa 12, so ilagay lang natin si 12 dito, and then kung ano yung makuha natin value, pag sinubstitute natin yung 12 dun sa x, that will be our value, internal forces dun sa mga distances na yun. Okay? So to check daw, di ba nakalagay kanina, kailangan yung derivative daw ng m with respect to x, dapat equal siya sa v natin, tsaka yung derivative ng v natin with respect to x, dapat equal sa v, no? So I hope natatandaan ng derivative. Okay, so let's check lang. Derivative ng moment with respect to x. So this is, so no, first function natin. So we have a derivative ng power. This will be negative 2 times 2 x 2 minus 1. Okay, times yung derivative ng x ay 1. Okay, plus derivative of constant or power pa din. So 1 x 1 minus 1 times 1 minus derivative ng constant ay 0. Okay, simplify. We have negative 4. Then ito magiging x. Then ito, since ito will be raised to 0, this will be 1 na din. So 108 na lang ito. Plus 108. So dapat daw ito, itong derivative natin, i-equal sa v natin. So if we check, ito is equal dito. So pag nag-equal siya, correct yung ating equation. Okay? So yan yun. Yan yung ibig sabihin nun. Next is derivative of v over dx naman daw. So yung derivative ng constant will be 0 minus 4 times 1 x1 minus 1 times 1. Okay? Or equal siya sa negative 4. Okay? Yung negative 4 na yon, ibig sabihin niya kung ano yung applied sa kanya. Ay yung applied natin is negative 4 o downward kaya negative 4 kips per feet. Okay? So ibig sabihin, equal siya dun sa ating applied load na kip per feet. Okay? So ibig sabihin yung shear and moment functions natin are correct. Okay? So yan yung para sa first segment natin. Next, paano naman daw kung dun sa other segment yung kailangan natin? So kung other segment yung kailangan natin, all you need to do is to get yung same formula natin o same natin, ikakat natin yung section. Okay, so paano ko papakita ito? So dito na lang. So ito yung section na bago natin, BB. So tapusin lang natin tong isang example na to, no? Section BB. So we have ito. Okay, then we have ito yung section natin, and then yung distributed load natin na na 4 is ayan. Okay, buo siya, no? Then meron tayong value ng dito, and then moment. So distance natin agad is x. Ito alam natin na 12 to. So ibig sabihin tong remaining natin is equal to x minus 12. Okay? So kunin ko lang yung value 108, and then ito is 15 ano nga yun? 1588. 1588. And then ito, since buo na yung distributed load natin, yung ECL niya is just 12 times 4 times 12. O yung 48 natin. Keeps. Buo na siya no? Na ang distance niya, kung kukunin natin, yung half niyan ay 6, di ba to? Kung 6 yan, this is x minus 6. Okay? So, ito yung ating, yung normal force, hindi na natin sasama. So, yung cut natin will be, ito yung V, and then ito yung ating moment. So, kunin natin yung summation of Fy is equals to 0. So, we have 108 minus 48 minus V is equals to 0. Okay? So, V is equals to 108 minus 48, that is 60. So, yung nakuha nating value, hindi siya in terms of x. So, meaning, kapag pinapakuha yung segment na to, ang segment natin ngayon, di ba, ito from 12 hanggang 20, no? So, yung segment natin ngayon is 12x hanggang 20, no? Pag pinapakuha yung segment na yan, ibig sabihin, constant yung value natin na 60 kasi walang naka-apply na load, which is tama naman, no? In between niya, walang naka-apply na load, so 60 feet. 60 kips, sorry. So, summation of moment at S equals to 0. Ito yung S natin. Taking to the right, counterclockwise as positive. So, we have yung 1588. And then, yung 48 natin, times natin ng X minus 6. Minus yung 108 natin times X. Then, plus yung moment natin is equals to 0. So, combine natin yung pwede i-combine. So, dito, transpose ko na lang muna lahat, no? So, we have 48, negative 48x minus 6, plus 108x minus 1588. Simplify, distribute natin to. Minus 48x plus 48 times 6, that is 288. Plus 108x minus 1588. So, combine natin, negative 48 plus 108, that is 60x. And then 288 minus 1588, that is negative 1,300. Okay? So, ito yung value ng moment natin. Shear, ito yung moment natin. Okay? So, pag kinuha natin yung derivative ng moment with respect to x, that will be equals to 60 times 1, x, 1 minus 1 times 1 minus 0. So, pag sinimplify, that will be 60, which is equivalent dun sa v natin. Okay? And then, pag kinuha natin yung derivative ng shear natin, that will be equal to constant, so 0, which is 0 nga kasi 0 tong portion na to. Okay? Sabihin, 0 o walang nag-a-act na forces dito. So, ibig sabihin, these equations are applicable for distances ng x na 12 less than x less than 20. Okay? So, ganyan po yung functions of x natin. Okay? Question po? Okay, so you have here some more beams na pwede yung pag-practicean, no? Ng pagkuha ng section. I'll try to make a separate video explaining kung paano kunin yung mga segments nito. Okay? Pero you can try this one. Okay? So if you don't have any more question, this ends our lecture for today.